to this fourth video about vectors. So in this lecture, we're going to find the magnitude and the unit vector. So let's say that I have this point. So I'll just have a 3D point, and let's say this point, and the coordinate of that point is 2, 1, 7. Okay, and let's say that this is the origin. Let me call this one as my point P. Alright, so what is the magnitude of that? Oh, okay, let's say I have another point. Let's say that is point Q, and my point Q is 7, 0, 8. Okay, 7, 0, 8. So I am looking for the vector QP. I'm looking for the vector QP for that displacement vector. Again, QP is equal to OP minus OQ. So basically this is your OP. Your OP is the vector 2, 1, 7, and then your OQ is equal to 7, 0, 8. Take a look, OP, OQ are vectors, huh? So therefore, your OP now is 217, okay, minus your OQ is 708. So therefore, your QP is equal now to 2 minus 7 is negative 5, 1 minus 0 is 1, 7 minus 8 is minus 1. Okay, so that is now my QP. So basically I need this one later on. Okay, so what do we mean by magnitude? Magnitude is basically, if I have this vector P, so this one is the length of the vector P. Okay, and if this vector P is xyz, then the length is symbolized by this one, or the magnitude, and that's equal to square root of x squared plus y squared plus z squared. Okay, now using this one, let's try to find the magnitude of QP. So we have here the QP. Okay, so let's try to find the length of QP. Length of QP. So that symbol is the length. So basically that QP is equal to negative 5 squared plus 1 squared plus negative 1 squared, which will give you square root of 27. Okay, now, so that is now how to find the length of 27. I mean the length of a vector. Okay, now we have what we called as a unit vector. When you say unit vector, so let me go back to this one, the QP. Please look at the QP. We know that the QP, let me just delete this part here. We know that the QP is square root of 27. This is what we have solved a while ago. Square root of 27. So when you say unit vector, and the direction of QP is equal to this. So this is the direction, negative 5, 1, negative 1. Okay? So when you say unit vector, we are looking for a vector that is on this direction. Okay? Same direction as QP. Let me write it down. Same direction as QP, but length of 1 unit. Okay, So therefore, if this one is square root of 27, all of that. So basically, this one here, the length should be 1 unit. So how will you find this one? How will you find that vector? So basically, that vector, which we symbolize as QP hots, okay? So the symbol for that is QP hot. Like there's a hat on the head, okay? QP hot is equal to the vector QP, okay, divided by its length, the length, which is this one, okay, which is equal to your vector QP is, what is it again? Negative 5, 1, negative 1, okay? Your vector QP is negative 5, algebra I plus 1 j minus 1 k minus k divided by your square root of 27, because it's the vector times the divided by the length of the vector. Or it's actually the same as this, 1 over square root of 27 times negative 5, 1, negative 1. Okay? So basically, just to summarize, okay, let's summarize it. Let's say that I have here this vector, and this vector is xyz, vector xyz, okay? And let's say that this is vector p. So the unit vector of the p, is equal to 1 over the length of that vector p, length times the vector itself, xyz, okay? But what is your length of p? Your length of p is 1 over square root of x squared plus y squared plus z squared times vector xyz. So this is your unit vector that is same direction as vector p, but with a length of 1 unit. Okay, please remember this summary here. That's the end of this video. Thank you.